Do you want me to talk you through this one since you kind of already have it down? You're almost there, I guess.
I kind of have an idea of it, but I'm not sure where to go from here.
Okay, let me go ahead and then grab it and we'll talk about it here. You're really close, but
Because I get like the idea of the power rule right here of how like basically you copy this in here and you kind of bring out the exponent to the front and then it's 3 minus 2 over here, but I'm not sure what you do with the derivative on the other side of it.
yeah. So let me share my screen and give you an idea here of what you're doing here. It's again, it's real close, so that's the good news. The original problem is really u cubed, where
Mhm.
u is 3x cubed plus 1.
All right,
Okay, so the derivative of this thing on the left here is 3u squared. Is that clear?
kind of, yeah.
Okay. Well, let's go through it. It's power rule. 3, you bring the 3 down, and then you
Mhm.
subtract 1 from the exponent.
Oh yeah, I
Okay.
understand that.
But then you multiply by u prime, or the derivative of the inside function. So
Okay.
over here on the right, let's do the derivative of the inside function. The derivative of 3x cubed is 9x, because you take that 3 and you multiply it by the 3 out in front, and then
Okay.
you subtract 1 from the exponent, 9x squared,
Squared. Okay.
plus 0 if you want. Okay,
All right. Wait, so why does it turn to a 0 on the right?
because you got plus 1. Derivative of a constant is 0.
Oh, okay. I just didn't know that, so I was
Yeah, I mean,
confused on that.
I've written these down for, and these are really important, really important to remember. D dx of a constant is 0. D dx of c times x is c. D dx of x to the n is nx to the n minus 1. Like, these have to be down really solid by now.
Okay.
Okay, because we're going to use them over and over and over again today. So now, like, going back to like your answer again, it's really close. It's 3 because of this 3 out in front.
Yeah.
But instead of u, you're going to put in the original 3x cubed plus 1 squared.
Mhm.
And u prime, instead of u prime, you're going to put in 9x squared off to the right here. So this is your
Oh,
u, this is your u prime.
okay. That's so much easier. I didn't really understand how to do it today. All right, so
This is
then
a
I'm
chain. This is a chain rule problem, and you're going to see chain
mhm.
rule over and over again. It's the hardest thing to get as a new calculus student. Is like, what do you mean by chain rule? It's what is the inside function? These are questions I'm going to ask you over and over again as we move throughout this assignment.
All right. Now I'll share my screen once again. Here we go. Oh, that one's just there.
Okay,
Pull
so
this
yeah,
out.
so all right, so let me snip this in. All right, I am sharing here again.
All right.
All right, so if you're seeing my screen, it's W equals 9R minus 2 to the 4th power.
Okay.
If we rewrite this as U to the 4th power, and U is this 9R minus 2, what is the derivative of this thing that I'm quickly?
Just for you
4U
Q.
times U prime.
Okay.
U prime is the chain rule part of it.
Okay.
Okay, so U prime is just 9.
Wait, why is it just 9?
So if you go back up to our list here, if you have a constant times x or a constant times any variable to the power of 1, it's just a constant.
Wait, so what's the power of what's the x? So constant times the x. What x the x here?
R.
Okay, so Rx is the x. Okay.
Yes, Rx is the x.
Mhm.
It really is the power rule, because when you subtract 1 from the exponent, what do you get?
You
1
get
minus 1.
0,
And anything with 0 power is
1.
1. So it's 9 times
Then
1.
and that -2 turns into a 0 because the constant is
Yes,
always 0.
yes,
Okay.
yes. Okay. So now you substitute in for your variables here, u. So instead of u, it's 9R minus 2 to the power 3. Instead of u prime, it's times 9.
Mhm. That turned to like oh wait, so you pull the 4 out in the front. Okay.
So I'm rewriting from this. Like I'm taking, you know, this 4 there, and instead of u, I'm putting that. Instead of u prime, I'm replacing it.
And that times 9. Okay, I am understanding this slowly.
This substitution that I'm making is really important as you're learning it. Eventually, you won't have to. Eventually, you'll just bring the 4 out in front, keep the inside function, use the power rule and make it a 3, and then take the derivative of the inside function and put it on the outside here.
Oh, so is it also fine if I put it as like 36 times 9r times 2 to
Sure,
the cube?
sure, but that they're
All right.
less concerned about your ability to simplify as they are your ability to take a
Okay.
derivative.
Okay, so to know the actual rule. Okay.
Yes, yes. The
Yeah, that's something
simplifying
that
is
she
just
said
extra.
today. She said
So
like
you will
that
get
it
it.
was more about the calculus part, not really the arithmetic part.
That's right. Okay, so let me grab this one and I'll share my screen here after I snip it in. All right, so if you're seeing my screen, you're seeing the same question there. This requires what I call a rewrite step, which
Mhm.
is to make this y equals s to the 15th power plus 3 to the 1/2 power. I am not taking a derivative. I'm just
Rewriting
changing it,
it.
rewriting it.
Okay.
Yeah, literally rewriting it. Okay, so this is really y equals u to the 1/2 power, where u is s to the 15th plus 3.
Okay.
Is that okay?
Yeah, that's fine.
So what is the derivative of y prime, or what's the derivative of y prime? It's 1/2 because it's power rule. U, you got to subtract 1 from that, so minus
Right,
1/2 times u prime.
Okay, that's
Now we need
clear.
u. Now we need u prime. So we come over here. What is u prime?
15s. Okay, 15s
14th
to the
power
14th. Okay,
plus 0
power
if we
rule.
want power rule. So now you take your u and you feed it back in here, and you take your u prime and you feed it back in here. So
Oh,
it's
okay.
1/2, and instead of u, you're going to write s to the 15th plus 3 to the minus 1/2 power, u
Mhm.
prime 15s to the 14th.
And now how do I rewrite that 1/2 stuff?
You don't have to. This is how you submit your answer.
All right.
Wiley should accept that. If it doesn't, we can work on that, but
1/2 times is
these are multiplying, I guess, even if
some parentheses around there. 15 s to the 14th. That's correct.
the only time you would simplify a derivative is when you need to use the derivative for another purpose. And so far, we have not been asked to do that. We've just been asked to find the derivative or calculate the derivative.
That is clear.
All right,
Awesome.
so I grab that. I'm going to share my screen. Every time I share, you probably the same deal. It's like 2 or 3 clicks, and you just want it to be 1 at this point.
Mhm.
Are you seeing my screen now?
Yeah, sure am.
Okay. Find the derivative of this function.
Uh-huh.
So this time it's y equals 3e to the u, and u is this 8t plus 1.
Mhm.
So we're always going back to something you know how to take the derivative of. The derivative is 3e to the u, e is itself, times u prime.
Okay.
So you know what u is. U is over here, 8t plus 1. What is u prime?
Oh, this would just be 8, right?
8,
8.
exactly.
Okay.
Okay, the t is like the x, so it's just that. So your derivative is 3e to the 8t plus 1 times 8.
Oh, all right. 1 times 18 times 8. That's correct.
Okay, let me snip this. Okay, so this one, I guess, slightly more complicated. I look at this problem and this thing I'm circling is the u. Okay, the u is the exponent. U is minus 11 t to the 7th power. And at some point, maybe you'll ask, or you'll think to yourself, well, how is he figuring out the u? The more you do these, the more it becomes apparent what u is. It's
Mhm.
usually an exponent. It's usually what's in parentheses or under a root or in a denominator. There's a few different options here.
So that u prime will be in negative 77 t to the 6.
You got it. So
Okay,
w
good.
prime is e to the minus 11 t to the 7th all times minus 77 t to the 6th power.
Awesome. So e to the negative 11 t to 7 over. All right.
All right, I'm going to snip in this question. All right, find the derivative of this function. So again, like I mentioned in the last problem, you sometimes make what's in parentheses the u.
Mhm.
Okay, so your derivative here is 1 over u times u prime.
Okay.
So again, you need this u prime
U prime is 4.
for, so it's y prime equals 1 over, your u is 4t plus 5
Okay.
times 4. Now you could put the 4 on top. It really doesn't matter here, but you know, this 4t plus 5 is on the bottom.
Mhm. I'll try to see how it reacts to the first way. 4t plus 5. Then multiply that times 4. That's correct. That works.
Why don't you try this one on your own if you don't mind? I'll happily work it out, but it's almost the same as the last one.
Okay. Yeah, because I'm trying to figure out how to do these on my own as well. Uh, I'll pause share real quick. Wait.
You don't have to share what you're working on. Just take 30 seconds here. I mean, I will show you. This isn't like, I'm not trying to keep you from getting help. It's almost like the last one. Natural log of u, 1 over u times u prime.
So the u t squared plus 3 and the u prime should be just 2 here, right?
What is the derivative of
2
t
to 2 to
squared
the
plus
t, 2 to the t, 2 to the t.
2t? Yeah.
All right. So 2t and then so ln t squared plus 3. They're just times 2t. I think that's
Yeah.
what I got. Is that
Yeah,
it?
go ahead and type it in. Let me see if okay, the derivative though of ln is 1 over.
Oh, 1 over x, right?
Yes, or 1
Okay.
over, you know, u if you keep using the u's like I've been.
So it'd be a 1 over t squared plus 3.
Yes,
Oh, okay.
that's the
Oh,
first
okay, I
part.
got it. All right, so ln equals 1 over x. So then I'll put the t squared plus 3 divided by x. And then divide that, then multiply it. No. No, I'm got that backwards. Is it
Okay,
1 over
okay,
t squared plus 3?
do this for me, Jack. Really, I will show you, but go back to the previous problem because you will see the pattern here. Can you just hit the back to the no?
Mhm.
It was gonna have you share back to your previous.
Oh, yeah, hold on. Yeah, it was 1
Okay, do
over,
you see how it's 1 over whatever is inside,
yeah, so it's 1 over
and
t
then you
squared plus
multiply
3.
by the derivative?
Then you multiply it by 2t here. Okay,
Yeah, so go back to your next problem. It's 1 over whatever's in the inside of it.
so 1 divided by t squared, and then plus 3.
Okay, and then you multiply by the derivative of the inside function.
Did I get that right, please?
Yes.
So there we go.
Okay.
Let's see if this one's like the last one.
All
All
right.
right. I have
I
no idea
will
what this is.
I will snip in and out. All they're doing in this problem is they're just increasing the steps after you take the derivative. You still have to be able to take the derivative. So I'll share my screen,
Mhm.
and like you've gotta say, okay, I can do this. I can take the derivative of this function.
Mhm.
So f of x is 3x minus 1 to the power of 3. It's really u cubed, where u is 3x minus 1.
Mhm.
What is the derivative of u cubed?
3u squared.
3u squared u prime. Perfect.
Mhm.
What is u prime?
U prime. For the u up top with the 3x minus 1.
No, this the here. I mean, you're seeing my screen, right?
Yeah, I see it.
Okay,
Oh,
u
never
is
mind. I
right
got
here.
that mixed up.
U is
Okay.
right here. 3x minus 1. What is u prime? What's the derivative of the right hand side?
Just 3.
Just 3. Perfect. Okay. Okay, like what we're doing is what's called a change of variable. And
Mhm.
you did this in other classes, but they didn't really tell you you were doing this. Change of variable. Okay.
Mhm.
There's more to it than that, but you always back substitute. You always go back to what you started with. So
Mhm.
yeah, it's 3u squared, but that's 3, and u is 3x minus 1 squared times 3. Is it
Oh.
clear? U is from here and u
Mhm.
prime is from here.
Yeah, I
Okay,
see that
and
now.
this is your derivative. Okay, there's your derivative. Now these things want what's called a tangent line. So here's what you need for a tangent line. Y minus y1 equals slope x minus x1.
Mhm.
So you need two things. You need a slope and a point.
Okay.
The slope comes from the derivative. Okay, so for the first one at 0, you have to find f prime of 0. That's why you took a derivative.
Okay.
So the derivative gives you the slope. So the derivative is 3 times 3 is 9. 3 times 0 minus 1 squared. You have to
Okay.
simplify that.
So that
3
turns into
times
0 minus 1. -1 squared is just 1. So 1 times 9 is 9.
that's your slope. So that's the first thing you need. You follow that? You need your
Yeah.
slope. Now you need a point. They tell you that x is 0. To find y, you have to put it in. You have to go back to the original function, find f of 0. 3 times 0 minus 1 cubed. I'm going back to the original function.
Mhm. So it's just
So
-1 here.
it is. So now to get the answer, all you got to do is substitute in your point, y1 and x1, and your slope into this equation.
Oh, all right.
Y minus minus 1 equals 9, x minus 0
Oh, that's it.
for part A.
Okay. So y plus 1. Oh, wait, never mind. All right. So what do we do now?
Well, if a bit of simplifying, y plus 1 equals 9x would probably be good to do here. Normally, you don't need to simplify it, but whenever there's zeros and signs, you're going to do that. So at x equals 2, you have to repeat the same two steps that you did over here on the right. You need the slope, which comes from the derivative. Okay, so the slope comes from the derivative. You need f prime of 2.
Okay.
So you're going back to this equation of your derivative, 9, 3 times 2 minus 1 squared.
Mhm.
And you have to simplify that.
So That's 6 minus 1, 5, 25. Wait, yeah, 25 times.
225, yeah.
Yeah.
Wow, it got big. Okay, so
Mhm.
it gets big. Then you need to find your point. So when
Mhm.
x is 2, you're finding f of 2. That's 3 times 2 minus 1 cubed, which is 125.
All right.
And you're using the same for the y minus y1 equals slope x minus x1. Your y1 is 125.
Mhm.
Your slope is 225. And your x is 2. Your x1 is 2.
Mhm. All right. So y minus. Plus 225. 225 times x times 2. And that's correct. On to number 10.
Do you notice that just as soon as you feel like you've learned something, like I got like, okay, I know how to take a derivative, maybe derivative chain rule, they just give you a new thing to
Yeah,
go along.
like completely. It's
Yeah.
like something that I haven't even looked at in class.
Yeah. I mean, I can't help with that, but that's what happens in this course. It moves so fast that every time you feel like you've got something down, you end up getting something new that feels like you've never seen before.
Mhm.
Okay, I'm gonna snip in this question and then share my screen. We'll just look at this one again together. All right, so for 2 years since 2010, daily oil consumption in China, thousands of barrels was approximated by this formula right here. Is daily oil consumption increasing or decreasing with time? So you can do this without any sort of calculus. If you were to graph this function, okay, is it a growth function or is it a decay function? And because it's E and it's a positive exponent, it's a growth function.
Mhm.
So is this increasing or decreasing?
Increasing.
Increasing. We don't even need any calculus to do that. Now we're going to verify that in part B, but it's some of these things you can do without having a lot of knowledge of calculus. Now, how fast is oil consumption changing at time t? This literally means derivative. And you should know that by now. You say, okay, like I'm in derivatives. I need to take a derivative. So the original function is 8938 e to the u, but u is 0.05 t.
Okay.
B prime is 8938 e to the u times u prime.
And u prime is just 0.05.
U prime is 0.05. Okay, now it wants an exact answer, which means that this time you do have to actually multiply some of the numbers together. It's e to the 0.05 t times 0.05. So you need to multiply those two numbers together. And I will do it as well.
What happened to the, oh, never mind. I forgot that the E looked like an E to the fourth, not an E to the U.
So I get 446.9 e to the 0.05 t.
E to the sixth. Versus 5T. Awesome. Oof, this is a layered one. Right here. This is all of it.
Okay, yeah, let me grab this a couple ways. Each one's going to be slightly different. So they'll grab the given. actually, give me just a moment here. If I don't snip it in the right way, it won't be good for us. So just another 30 seconds here. All right, I'm going to share my screen and we'll look at these together. So this problem here, let me share it with you. It wants you, it's like this thing on the right is what's given. And you remember doing composition in previous math classes?
Yeah, I remember that.
So like in this case, like u is essentially the inside part.
Mhm.
So like when you get a composition like this, the derivative is f prime keep g of x times the derivative of the inside function. Okay, now, and think about this. If this is f of u, it would be f prime of u times u prime. Well, u is g of x, so u prime is g prime of x. So now you have to evaluate at this value of 4. So you have to literally do f prime of g of 4 times g prime of 4.
Mhm.
So you got to retable here. What is g of 4? G of 4 is 2.
Mhm.
So f prime of 2 times g prime of 4.
G prime of 3.
G prime of 4 is 6.
Oh, wait, never mind. I didn't look at that correctly.
Yep. So now we're going to go f prime of 2. So f prime of 2 is 7. 7 times 6 is 42.
42.
So I mean, if you just care about the answer, that's the answer. But you will be expected to do problems like this and even more complicated ones.
On the test.
Yeah. So just to try to follow these as best you can. But you really do got to be comfortable with the idea that there's an inside function. Its derivative goes on the outside. Okay. So now let's go on to part B. Oh, you know what I did is part B. So let me replace this. What I did is actually part B, believe it or not. Part A is much less complicated. Let me go back to part A. Part A is just evaluating the function. There's no derivative. So this one just says, hey, x is 4, put 4 in for x. So you need to find f of g of 4. So if you go back and look, your g of 4
It's just 2.
is 2. And so you got to find f of 2, which is 1. So the answer to that one is 1. But the second one is what it is. It is correct. It's what I mentioned there. Now, so okay, I get what they're doing now. Sometimes I wish I had a little more clarity on that. So now part C is just the reverse. It's saying, okay, here's 4, but now it's g of f of x. So you've got to find g of f of 4. So you first calculate, well, what is f of 4? F of 4 is 3. So this becomes g of 3. And then you go back and you're like, okay, what's g of 3? G of 3 is 4. So that's your final answer. For part D, you have to actually do a derivative. So let's look at this. Snip this in. All right, part D. So again, it's kind of like this. It's kind of like, okay, it's g of u, and u is the f of x. So the derivative is g prime of u times u prime, or g prime of f of x times f prime of x. So the inside function stays the same, but then you multiply by the derivative of the inside function. The outside function takes its derivative, and then you evaluate it at 4. So you need g prime of f of 4 times, that's a 4, times f prime of 4. Okay, so f of 4 is 3. So now we need g prime of 3.
Okay.
I don't know what that is. We'll have to go back. Look, G prime of 3 is 12. Great. And then we need F prime of 4. F prime of 4 is 7. So 12 times 7 is 84.
84. All right. That's all correct. I think I want to go back and maybe try to switch up the numbers. Try to figure it out.
This one or something else?
Some of the older like derivative ones that I wasn't really kind of getting the hang of.
Okay, are you asking to do some like the first ones we did today?
Yeah, like let me
Sure.
share it real quick. That's kind of what I make the most of the time. So I want to kind of see if I can do it if I switch up the numbers. What do you think would be like a good number here that I could try out?
Yeah, so I've got them all on the screen on my screen here. I'll just make some up here for us to work on, if
All
that's
right.
okay.
Okay, so you
with
want me
you.
to pause the share and you draw it out and I do
Yeah,
it and then you could do it off screen?
Yeah, so what's ideal now is I'll give you a problem. I'll say, okay, let's Jack, why don't you find that if y equals x squared plus 3 under the square root there, you figure out y prime and you just take 30 seconds, see if you can work it out on your own. And then I'll work it out with you or show you the answer or both, kind of thing.
Okay.
So if you got some pencil and paper, give this one a try and let me know.
Right.
Where you at, how you doing on it.
X squared. Two. I think that's it. I think I got it. It's it 1/2 times x squared plus 3 to the negative 1/2 power times 2.
Okay, what is the derivative of x squared plus 3?
Just 2.
2x.
Oh, never mind, 2x.
2x.
One little mistake. So
It's big though. It really is. I mean, this is u to the 1/2 power. Really is important. So let's do another one like it. I mean, I tend to know what you'll see on a test, and this is this is one of them. So let's say it's
how do you get like the 1/2 and then the negative 1/2 power in the first one? I'm still not clear on how that works.
so you always bring this number out in front.
Yeah.
Whatever it is, you bring it out in front, but then you subtract 1 from it to get this number.
Yeah.
The exponent.
Oh, okay. Oh, I see it. All right.
Okay, so let's try another one here. Let's say it's 5x minus x over 5 minus or plus 5 over x to the 2/3 power.
Power x to the 2/3 power. Okay.
I would recommend a rewrite before you take a derivative and deal with any negative exponents or anything that's maybe not clear from the way this is written, because this illustrates kind of the 3 types of derivatives that are problematic for first-time calculus students.
Okay, so for rewriting, okay. What would you think? What would you say for like rewriting? Like, oh,
Yeah, I'm going to show you here. It's like putting the coefficient out in front and then using negative exponents, but bringing it up.
-1. All right,
Which you were told not to do. You're like, don't write it with negative exponents. But now I'm saying, yeah, that's the way to do it here.
Okay, so now that I have that, so y equals. All right, now I find the derivative. Find the. All right, so the u is this 5x minus 1/5 x plus 5 x to the negative first power, negative first. All right, and then the u prime of that is 5. minus 1/5. Okay, so for the u prime, I get minus 5 minus 0. I get negative 1/5 for the negative prime, and then for the actual u prime, Oh, you, nice, yeah.
What step here didn't work out for you?
I keep forgetting the power rule and for the U that I apply, and then I put the U prime. For the U
Okay,
prime, for the oh, you get a -2. Oh, because okay.
you're
I
subtracting
kept,
one.
yeah, I forgot that I was subtracting one. I thought that I was adding
Okay,
one to it.
let's just go back here and let's do something simpler, which is let's just do some power rule derivatives because this has really got to be key.
Perfect. Yeah.
Okay, so let's say f of x equals x squared minus x to the -3 plus 5x to the -1 minus 2 like that. Okay, so this is your power rule derivative. Okay,
Mhm.
your derivative here. You're going to always bring that exponent out in front. 2x. And then what do you do with this exponent? You subtract 1 from it.
So you get, it's basically just 2x to the first power.
Right. Now you can write 2 minus 1, but eventually you got to write 2x.
Hmm.
2x to the 1. Like eventually you got to be able to go right to that step. Now, how
I
about the
get
next one here?
I get +3 to the -4th.
3x to the -4 power.
All right. So I got
Okay.
one right. Then I get -5. Yeah, to x to the -2nd power, and
Okay.
then that 2 just cancels out. It's just gone.
Well, goes to 0.
Mhm.
Okay. Now I was really helpful in how I wrote this, but like you're not going to get it that way on a test. Like you're
Mhm.
going to get a function that you have to rewrite. And one of the ways that you might have to rewrite is like, okay, it's the square root of x minus the cube root of x squared minus 7x to the 1/6 power
Mhm.
plus x. And you have to be able to take a derivative of something like this.
Mhm.
So again, I would recommend a rewrite.
So I would
First,
do like x to the 1. No, wait. How could I do it? Could I do x to the 1/2 for x?
right. Now here's why, because there's really a 1 here and a 2 here.
Yeah.
Now
Oh,
use that information to write this as x to what over what here.
so okay. So then minus x to the 2/3 power.
Okay, that's good. Minus 7x to the 1/6 power plus x. You've not taken a derivative, but now you can. Now it's just straight power rule.
So -7/6 x to the 7/1/6. I get -5/6. So -7/6 x to the -5/6 power.
How about the, did you do the first terms or first two already?
Yeah, I did.
Okay.
And then
What did,
the last one is right, so 1. Then the last one's just 1
okay,
plus 1.
what's the derivative of this first term?
Hold on. So it's 1/2 x to the -1/2, and then -2/3 x to the -1/3, and then -7/6 x to the -5/6 power, then +1.
Good.
Yeah, you got it.
Okay, so if you truly understand that, you won't have a problem doing this next one.
Mhm.
It's going to look a little weird. X to the pi minus 2x to the e. I want you to take the derivative of this.
It's 2x to the e. All right. Um,
These are still power rule problems.
so this still, all right, so x equals, do I do pi
If
x, pi -1
yes,
power, and then minus, okay, so do I do 2e x to the e -1?
yes,
Ah, I did it right.
yes. Okay, so now all we're doing in the next part of this course, like the stuff that you were just showing me today that you wanted to work on, is we're taking a problem like this one.
Yeah.
Just grab this. And we're making it more complicated by doing the following. Let me snip it in. We're just raising it to like the 6th power.
Mhm.
Okay. So the derivative is first you apply the power rule on the outside
Mhm.
because this whole thing is u. Like, do you see that this is really u to the sixth?
Yeah, pretty much.
So the derivative is 6u to the fifth, that's power rule, u prime.
Oh. Oh, all right.
So it's 6, and then you grab all the stuff that you just did, x to the 1/2 minus x to the 2/3 minus 7x to the 1/6 plus x to the power 5, and then u prime is that line that you just told me, that 1/2 x to the minus 1/2 minus 2/3 x to the minus 1/3 minus 7/6 x to the minus 5/6 plus 1.
That's good. That was what I wanted to understand because yeah.
Okay, so let's do one that's not as complicated that you can do out completely. Let's say y equals 5x squared minus 3x plus 2 to the power of 4. I want you to find y prime, please.
All right. It's just -3. Just 10x. 10x minus 3. All right. I think I got it. 10.
Okay, what's your final answer?
So I get 4 times 5x squared minus 3x plus 2 cubed times 10x minus 3.
Perfect.
All right.
Okay, so the only way like I make this more difficult is to just change kind of like I call it scramble, but I give you things that maybe you're like, I don't know how to do that. Like 1 over the square root of 4x squared minus 3x.
All right. 4x squared minus 3x. All right.
This requires a rewrite before you do it.
Is this like 1/2 times? Wait, no.
It is a
That's
1/2 because of that, right? Like it's 1 over 4x squared minus 3x to the 1/2 power.
Oh,
But how do you rewrite it so that it's just 4x squared minus 3x? What's the exponent?
I'm not sure. What do you do?
Okay, so if it's 1 over x, this becomes x to the minus n.
Oh, you make it negative. Oh, never
And
mind.
if it's x to the minus n, it's 1 over x to the n. So this is minus 1/2. So yeah, I'm asking for this that I'm circling, but really you should think, oh, it's really this.
No, I see it. All right. Then I think I know what to do. Or
Okay.
and then
Go ahead and take a derivative.
it's just -1/2 times squared minus 3x, and then it's minus 3/2 power, and then I have to find the derivative, and I get times basically just times 8x, and then minus 3. All right, so -1/2 times 4x squared minus 3x to the -3/2 power times 8x minus 3.
Perfect. Okay, so now let's look at some of the other functions that you showed me earlier. You showed me some, like, let's say f of x equals 8e to the minus x squared plus 2x power. Okay, so this time we're actually going to say, okay, it's really 8e to the u, and u is minus x squared plus 2x.
Okay.
So see if you can take a derivative from here. You got to take a derivative of this, and then you got to take a derivative to the right also.
So AE to U. Okay, so you find the derivative of the x squared plus 2x, the negative x squared.
I
Okay,
would do this one on the left first, because that tells you what you need.
Oh. All right. So E to the.
So the u prime here is why you need to take the derivative of this stuff on
The right.
the right. Yeah.
Yeah, and you get negative. All right. Negative 2x. Yeah, plus 2. What do you do next?
You substitute back in. You have your u and you
Oh.
have your u prime.
Oh, you just multiply it?
Now you got to kind of be careful here that you show this u prime in parentheses.
Mhm. Are there any more tricky ones like that?
There's lots.
Hmm.
Let's do another one before we close out here. Let's go y equals 7e to the minus 2t minus 1 over t.
Ooh, okay. Wow, okay. Let's see.
If you break it apart like we've been doing, you say, okay, it's e to the u, and u is really minus 2t minus 1 over t.
Mhm.
Okay, then when you take a derivative, it's really not that hard. Like e to the u is great. E to the u times u prime.
All right, so
Right.
then for the prime, yeah, I guess a 1. Yeah, I just get -2 for the prime on that one, and then
No, u prime
negative.
is, yeah, I mean, you've got both terms that I take a derivative of.
Mhm.
-2, and then what's the derivative of the second part?
Oh, that's just +1.
Well, +1, but then you subtract 1 from the exponent,
Oh, uh, yeah, t
to the
negative. Oh,
-2.
I always forget that.
So you got to know your power rule. You got to just really get it down, like, until you do them until you get it down, kind of thing. And then you back substitute. So you replace u is -2t minus 1 over t, and u prime is -2 plus t to the -2 power.
All right. Who do one more?
Yep.
Want to see if I can get this down cold.
Y equals -3e to the -3x plus 3 over x squared.
For x squared. Okay. So then -3e by itself, and then I want to find the. Okay, so then the 1, -3, -3, and then what do you do to get rid of the x squared? Separate the x squared and the 3 over x squared.
So 1 over x to the n equals x to the -n. And if you put a number up here, like let's say it's c over x to the n, c is a
Yeah.
number, it becomes cx to the -n.
Okay, so this would be 3. This would be 3x to the -2.
Yes.
Oh, okay. That's all I had to do. So plus 3x to the -2. Okay. So then that turns into -2 times 6, and -6x -3. So negative. All right. Think I got it. Is it -3e to the -3 minus 6x to the -3 power?
Your u is your u. You're not taking a derivative of the exponent. You're just keeping it. -3x plus
Oh yeah.
3x to the -2. And then
Then
you
you
multiply
multiply
by the derivative, which is -3 minus 6x to the -3.
perfect.
All right, that does take us to the end of our lesson today, Jack. Thanks so much for scheduling. I'll see you next time.
Thank you. You made it very clear. I really
All right,
appreciate it.
awesome.
Have a nice
Have a
day.
great night. Bye.